Our first step for hypothesis testing is to look at the concept of writing the actual hypothesis that we want to test. There are always two hypotheses that we write. Let's look at an example. Our directions are to write the null and alternative hypotheses. Researchers writing in analysis of verbal behavior reported that the mean listening time of 16-month-old infants exposed to non-meaningful monosyllabic words, for example, gif, cham, gak, is 8 seconds. So in this particular example, we have a couple words that help us in writing the hypothesis. First, I want to notice that this example is talking about the mean. I also want to notice that it says the mean is 8 seconds. So when I'm writing the hypothesis, I want to use mu, the population parameter, for mean. And one of my hypotheses has to capture this claim that the mean is 8 seconds. So we are going to start by writing the null hypothesis. This can also be called H0, and it has the little 0. And for the null hypothesis, we always include the equals. So we're going to say the mean, which we'll use in symbol form mu, equals 8 seconds. And that will be our null hypothesis. Now our two hypotheses need to be mutually exclusive. So we want the true opposite of this. Our prompt does not talk to us about whether they would like the mean time to be more or less than this, or whether it's thought to be more or less. So for this example, when we write our alternative hypothesis, and there's two notations, I usually use HA for the hypothesis alternative, but some people use H1. Seeing this is 0, they make the next one 1. Doesn't matter which notation you use at all. So again, this hypothesis is going to be about mu, and this hypothesis, exact opposite, is going to be that mu is not equal to 8 seconds. So it could be that the mean is greater than 8 seconds, or the mean is less than 8 seconds. Let's take a look at a second example. Again, we're asked to write the null and alternative hypothesis. Cigarette advertisements are required by federal law to carry the following statement. Warning, the Surgeon General has determined that cigarette smoking is dangerous to your health. However, this warning is often located in inconspicuous corners of the advertisements and printed in small type. Suppose that the Federal Trade Commission claims that 80% of cigarette consumers fail to see the warning. So when we think about writing a hypothesis for this example, we notice that this is a percent. And so we're dealing with a proportion. We use P as the population parameter, and in the proportion method, we give that percent as a decimal. So moving my decimal 2 places, 80% would come out to be 0.8. So this last statement, the Federal Trade Commission claims that 80%. So that is saying that that proportion would equal 0.8. Remember, when we're writing the hypothesis, we always work with the parameters. So that's why I'm not using p hat. And we always put the equal statement as part of the null. So my null hypothesis, H0 or H0, is that the proportion is exactly 80%. Now, the alternative hypothesis, and I'm using HA, but you could also use H1, is going to also start with P. The alternative would have a sign other than equal, and it will have the 80%, the 0.8. So the advertisers in this case, they would not want the scenario where more than 80% fail to see the warning. They would argue against the Federal Trade Commission that it would be less than 80%. So rather than using P not equal to 80% for my alternative hypothesis, instead I want to view it through the lens of the context of the problem. And I'm going to use that the proportion would be less than 80%. So the cigarette advertisers would be saying, "You're wrong, Federal Trade Commission. People are seeing the warning where we put it in fine print in the inconspicuous corner." These two examples are again mutually exclusive. This is exactly equal. This is anything less, but this is not two-tailed because more than 80% would not help the advertiser's case. Let's look at a third example. This time again, we're to write the null and alternative hypotheses. A lot of focus has been placed on the nutritional value and calories in school lunches. A nutritionist conducted a study of high school lunch menus. During the state-mandated testing period, school lunches averaged 850 calories. The nutritionist claimed that after the testing period ended, the average caloric content increased because popular desserts were once again offered. So as we look at writing hypothesis for this scenario, take a moment, pause the video, and see if you can figure out, do we want mean, proportion, or standard deviation? It says that they averaged, so that concept of average would tell me that I want the mean. Again, see if you can pause the video and write your two hypotheses. For the first hypothesis, my H0, I want an equal statement. So for this one, I will use the mean is equal to the 850 calories. Next, for my alternative hypothesis, the nutritionist is claiming that the average caloric content increased. So they're not claiming that it's just not equal to. They're claiming that it's greater than. So I use the mean greater than 850.